Hi, so today we begin the big chapter on series. Before we do so, we're going to review some concepts that you learned in previous math classes, such as a sequence. And a sequence you might have recalled from back in elementary school when they presented to you guys a series of shape and then asked you what the next shape in this pattern would be, or what your prediction for the shape would be. Then we moved on to sequences in math classes such as Algebra 2 Trig and Pre-Calc Honors, where you saw a list of numbers and there was some sort of pattern tied to it. And so if we take a look here, 1/3, 1/6, 1/11, 1/18 is just a list of numbers. Therefore, we would describe this as a sequence. So sequences are either divided into two categories, one that's finite or one that's infinite. And it depends on whether or not, as you guys would recall, whether or not the series went on forever or whether it was truncated. So for example, if 1/38 ended right there, we would call that a finite sequence. So down below here, we're given a general term for the sequence rather than the list of numbers. So what we're going to practice doing is writing out the first 6 terms given this general term. N stands for the number of term. So in this case, I would describe this as the nth term. So given a sequence of terms, this would be my nth term. And over on the right hand side, the nth term gives us the rule for which we're going to find the other terms. So n is our index. N is an index. And it kind of helps us keep track of what term we're on. So we're going to start with 1 being the beginning value of n. So index starts at 1. And so all we do is plug 1 into the rule. So when we plug 1 into the rule, we see that the top is going to be -1 to the first, and then positive 1 squared plus 1. So we get a sub 1. Plug 1 in on both sides, we get the first term is -1/2. The second term, when we plug it in, squaring a negative is going to give us positive. Squaring 2 and adding 1 is going to give us 1/5. Go ahead and come up with the first 6 terms for me. So we see here we have 6 terms, and the 6th term is 1/37. We would also describe that, just so you guys know, as a sub 6. And the ... or the ellipses that follow indicate that we're going to go on to infinity. This is an infinite sequence, and my 90th term, which is also asked in the question, my 90th term would be represented by 1/8101. Okay, so what we're going to do, we're not going to worry about B. If we have time in class at the beginning of next class, I'll show you guys how to do this. However, you do not need to know how to graph a sequence on the AP test. And I think you guys can predict what's going to happen as you look at the graph. Without looking at the graph. So if you're looking at the series of values that you have there, beginning with the first term being -1/2, and then, so if I'm picturing my xy axis, I'm picturing that the first term is -1/2, so let's say we are here, -1/2. So let's say at 1, you have -1/2, the second one, +1/5, -1/10, and so on and so forth. And I want you guys to think about this. What is happening to your series as you approach infinity? And so whenever we have that sort of discussion, we throw in the phrase limit. So really, what is the limit as n approaches infinity of your sequence? What does it approach? And so you guys might look at the graph roughly that we did here and notice as you're trying to graph the values of the terms are getting closer and closer to the x-axis. In fact, if you look at your 90th term, you'll notice that the values, although they alternate, they are getting larger on the bottom. A larger bottom means that it's a smaller number, and that smaller number, we would make a prediction that as you went out to infinity, that it would approach 0. So I would describe this as so it's jumping back and forth. And a new phrase for that is oscillates between the x-axis. And we call this a special type of sequence. We call this an alternating sequence because it's alternating between negative, positive, negative, positive. And the part of the rule that's going to give us a hint as to the fact that it's alternating is the top portion of your rule. And if you think about it, if you plug in a odd number, you're going to get -1 to an odd power, which is going to give you a negative number. However, if you plug in an even index, you're going to get something that is positive. You're going to square or take it to the 4th power. So that's going to result in something positive. So we see the results being an alternating sequence. Okay, so on example 2, you're given another nth term, this time described as n-1 over n. I'm going to have you guys pause and go ahead and fill out what you think the first 6th term and the 90th term of this is. Okay, so you should see that you have the first 6 terms being defined as if we started the index off at 1, that you get 0 over 1 or 0, and so on and so forth, plugging in 2 next, then 3, then 4, and until we get to the 90th term where we get 89 over 90. If we observe this sequence, we would notice that it's approaching a particular value, in which case the above had gotten us a larger bottom, therefore we said it was 0. However, this is getting closer and closer values for the numerator and denominator. They're approaching each other. So if you guys think of something that is similar on top over something that's similar on bottom, think of relative rates of growth. This limit should be approaching 1. And our last example here is what we call a recursive sequence, where the secondary term is going to be dependent on the primary term or the first term. So your first term is always given to you in a recursive sequence. So in this case, C sub 1 represents your first term. And thereafter, you're given a general term that defines what your second term, third term, and later terms are. And notice that it did say start with n is greater than or equal to 2. So when n is 1, we're going to assume it's 4. And then after that, if we think about how to define this, if I plug 2 in for n, over on the right-hand side, 2 minus 1 into this spot right here is going to give us C sub 1 plus 2. And so if we think about that, it's going to say, this really says your second term is dependent on your first, whatever your first term is, plus 2. So if you do a substitution into here, it should be 6. And since this nth term is dependent on the term before that, we can continue that pattern and continue to add to our previous term. So why don't you guys go ahead and fill out the first 6th term and what you think the 10th term of the sequence is. Okay, so we see our 10th term is 22. So I want you to look at example 1 again on our limit question, and we saw it approach 0. On example 2, we saw it approach 1. And finally on this example, as we continue to add 2, we notice that this number continually grows larger. So there is no limit as n approaches infinity for this sequence. We would say it does not converge. So no limit as n approaches infinity, this sequence does not converge.